Hey guys, welcome to the first version of the online classroom. Remember, the point of this is for you guys to fill in those notes that are in front of you, the Chapter 11 motion notes. If you can do that from my lectures, that's awesome. You may have to fill in a few things from the book, but have those done, ready to go for tomorrow. We'll take a quick quiz, it'll be 5 questions straight from what you got written down, and things should be very easy. So, what we're going to talk about tonight is distance and speed. So, how fast is fast? This is a really easy concept that I think most people confuse a lot. They use the words speed and velocity interchangeable, and hopefully by the end of the night you'll realize that they're not actually interchangeable at all. So, pay attention to my mouse. I'll be moving around. I'll have some drawings going for you. And remember, if you don't quite get it 100%, take the time to pause. Don't feel free to do that. You can listen to what I say again. And remember, just come prepared with some questions tomorrow. And you can write those questions down on the left side of your page where it says 5 possible test questions. So let's get started. So speed. Speed is just a measurement that relates distance and time. That's really all it is, guys. It tells you how far you went in a certain amount of time. You know this. You've seen speed before. You're very familiar with speed. But we're going to add some technical aspects to the definition that you think of speed. But in order to understand that, you first have to truly understand what motion is. And I have a picture down here, because you guys know I like pictures a lot. And if you look at figure 1 compared to figure 2, how in the world are you going to tell me that you know that object moved? Then the answer to that clearly is that the tree is in a different spot than the car in position 1 and when compared to position 2. So either the tree or the car moved, and we can use our common sense that most of us have. You know who I'm talking about when I say they don't. And you can assume that the car moved. The tree in this would be our frame of reference, what I've defined up here. So system used to identify the precise location of an object. In other words, the tree was our frame of reference. Do we know that the car moved, or the car was in motion? The change in position relative to a reference point. So you have those on your sheet. Those are A and B on your sheet. You can fill those in. And remember, I'm going to keep rolling, but if you need more time, go ahead and hit pause button and come back to it. So we look at distance versus displacement. And these are probably the two things that kids mix up a good bit. And it's okay. It happens often. So distance is how far did you move? The total distance traveled. How much ground was covered is what we have in quotation marks there. And the total displacement is the distance and direction of an object's change in position from starting point. So, this picture right here is absolutely perfect when wanting to describe this. So if we look at this picture here, we can blow it up for you. You see that the red line is the path traveled by, let's say, a car, okay? So the car is traveling along this line, but really, from start to finish, it went from here to here. The distance traveled would be this red line that we followed, okay? That's how far it went. The displacement is really the distance from start to finish. So displacement is only shown from here to here. We could say that the distance here traveled is much longer than the actual object's displacement. If you don't understand that, we have another example here. Got a picture of a track. So I'm sure my track runners will love this one. I think a track is, 400 meters long? If I mess that up, sorry. Didn't mean to offend anybody. But let's say it's 400 meters, and I'm going to draw on this for a second. Yes, Sneed knows how to use a smartboard. So, here's my track. Let's say we start right here, and I travel all the way around this track, and I touch the grass a little bit, my bad. I'm a really bad runner. And I finish there. My total distance I traveled would be 400 meters. My displacement, however, was 0. And the reason my displacement was 0 is because I started, went all the way around, and finished exactly where I started. So I had no displacement there. And we'll talk a little bit more about that tomorrow if you don't quite understand that. I'll have a few stories to help explain that. Now, displacement for you honors kids is a vector quantity. Something that you've probably never quite heard before, but it's okay. We're going to discuss it really quick. A vector vector is a quantity that includes a direction. In other words, I need to tell you that it was 40 miles east or 40 miles left. I can't just tell you it was 40 miles. I have to give you the direction. We can represent these directions mathematically using these guys over here. Okay? So you can see vector A was this guy. Here's vector B. Notice the line gives you the magnitude and the arrow gives you the direction. And what I mean by that is you can look at A and see clearly that A was smaller than B. In other words, let's say that car traveled less far, or not as far as when it traveled here at B, if that makes any sense. So vectors give you a quantity and a direction. The length indicates the magnitude, as we're saying down here, and the arrow clearly indicates the direction. Alright, moving on, guys. Remember, pause if you need it. Speed. Now we can finally go to it. Now that we understand distance and displacement, vector quantities, all those good things, we can finally hit speed. Speed has an exact measurement because fast and slow is not good enough. You know that in science. We have to complicate things. So speed is how quickly something moves from one place to another. Distance is per unit of time and does not include a direction. That is one of the most important things, that speed is not include a direction. Now, velocity on the other hand is speed in a particular direction. So, for instance, if I simply said 30 miles per hour, would that be a speed or a velocity? The answer clearly is a speed, because I just gave you a distance, or a distance in time. If I said 45 meters per second south, that's now a velocity because I gave you a speed in a certain direction. Velocity, once again, is also a vector. It's a quantity with a direction. So it's not just speed, it's speed and a direction, which is a very, very big difference. So moving on here, keep in mind, speed is not a vector. Velocity is, however, a vector. It is speed with a direction included. And the math part, you knew we had to do it, guys. We always are going to get down to math now here at the end. Remember your triangle that we taught you earlier, okay? The triangle is going to be huge, huge importance in these physics sections. So the math, we can say that speed, as you see up here, is equal to distance over time. Alright? And velocity has the exact same equation, but if you were going to write out a unit for velocity, it would need to include a direction. Because once again, velocity is a vector, which is hugely important, guys. We've got multiple different kinds of speed, which gets really confusing sometimes. But we can almost always calculate average speed. That's what we're usually doing. It's the total distance traveled by the total time traveled. So, okay, so you could say a speed on a trip from Charleston to Orlando. Now, there's also instantaneous speed, which is a speed at any given specific point of time. In other words, if you were traveling from Charleston to Orlando, let's say you took a pit stop. You got out, you had to use the bathroom, you got something to eat. At that point in time, your instantaneous speed would be 0. Your car is not moving. But let's say you got back on the highway and all of a sudden you were going a little bit faster. You're traveling 60 miles per hour. That is your instantaneous speed at that point. If I took the total distance you traveled and the total time it took, we could calculate an average speed. So, practice problems real quick. The answer is already given to you, which is terrible. But, here we go. What is the speed of a commercial jet which travels from New York City to Los Angeles? 4,800 kilometers in 6 hours? Well, you would once again set it up using your triangle. Right here, I have that highlighted for you. Distance over speed and time. Over here in the problem, I gave you the distance here. I gave you the time, 6 hours. So you would plug in 4,800 kilometers over 6 hours. And that gives you your wonderful answer of 800 kilometers per hour. Notice, I am not specifically saying that it has to be in meters per second, miles per hour, feet per minute, okay? Whatever I give it to you in the problem. So up here I gave you kilometers, and I gave you hours. You can spit that back out at me right as I gave it to you, unless I say specifically it has to be in meters per second. But I'll include that in the problem. So don't convert unless you have to. We could also take this here, guys, this 800 kilometers per hour, and change it to a velocity if I wanted to. The only thing I would have to do is add a direction. So for the third time, the difference between speed and velocity is that speed is distance over time, and velocity is distance over time with a direction. Alright, so I'm going to skip ahead now, guys, to not this one. You can pause it here and try it. You can check your answer. I gave it to you. But we're going to go to these two. Alright, so what I want you to do right now is hit pause on your video. Do it now. Don't tell me you're going to do it and not do it. I know you guys. Hit pause now. If you haven't hit pause, I'm going to be mad. Alright, now I'm going to go over how we solve these problems, okay? So, train travels 100 kilometers per hour for 2 hours. What distance has it traveled? So I'm going to work on it down here. So I always tell kids right off the bat, write out your formula. Speed equals distance over time, right? We can plug that into a triangle. We know that distance goes on top, speed and time on the bottom. All right. Then I gave you the speed, so write that out, 100 kilometers per hour. And I gave you the time, which was 2 hours, okay? Clearly I gave you S and T, you're solving for D. Remember, you cover up the D and you get D equals S times T equals 100 times 2, and you get 200, these guys will cancel, kilometers. So your answer, 200 kilometers. Congratulations if you got that one right. And we'll move on to the next one. Look at that, I have it magically written in blue this time. I changed colors, that's how I do it. So, second question, a hawk travels at 10 meters per second for 600 meters. How long did it take? So, write down what I gave you. Once again, I gave you speed, 10 meters per second, and I gave you a distance, which was 600 meters. Once again, what I did not give you was a time, and that's what I asked you to solve for. So you know the formula for that equals, T equals D over S. Plug in your numbers now. We have, oops, I'm messing this up. Plug in some numbers, 600 meters divided by 10 meters per second. And what does that come out to? I don't know. I can't do math in my head. Somewhere around 60 seconds. I hope that's right. And of course it's right, because I never make mistakes. So, that concludes our session, our first virtual session of notes. I hope you guys enjoyed it. And remember, if you didn't get everything, if you're unsure about some concepts, that's okay, because we're going to take all day tomorrow to hit these. We've got some fun activities for us to do. We're going to practice some of these problems, and we really should come out away from this with a better understanding. So be prepared with your questions. Remember, right now, take this time on the left-hand side of your page to fill in the 5 possible test questions. If there's anything on your sheet that isn't done, you can quickly look through the book for those, have them filled in, and tomorrow we'll take that 5-question quiz and we'll be ready to go, guys. Have a good one.